Yalla. No worries at all. Yalla. Hello and good morning. Again, we are going to talk about chapter 13 is about, you can see, vector value. Because later we have a vector field, so we are going to talk about vector value. Later on, we are going to talk about vector field in the next chapters. So the important thing is what? Close the door, please. Thank you. So the important things here, maybe you are not going to the detail. I'll just give you the brief information. Generally, when you have a vector valued function and motion in the space, so totally we are going to talk about application of the vectors, especially in the physics, especially in the engineering for the motions and when you have a change. So you can see from any particle, when you move it, we have on the space, we have a vector, we have a curve, we have many things with it. You can see each vector can be, we say that x is like that, y is like that, z, and we have t. So because we have a parameter, each vector can be represented as the 3 parameters on the x-axis, on the y-axis, and in the z-axis. Maybe you are going to up or going to down. So depending on that one, we call as a RTR as a function for the any things that we have. Okay, dears? So you can see from here, when we try to collect all these dimensions together, we have I, J, K, right? And each one, they have a, instead of number, before we say that, we say, for example, in the vector parametric equation for line, or any normal vectors, or just only vector, we say V equal to 3I 2J 5K, for example. Now we have something else. We have a RT. What do you mean by RT? Because I have 3TI 2TJ 5 maybe T squared K. Or maybe another RT or another function, change it to sine TI cosine TI TJ T squared K. You can see the coefficients change to the variables. So that's why we called function. Understood? And of course, when you have a parameter, t should be between something. For example, you say 2 pi. Clear? Easy? So we just change vector to the vector valued. So with the value function, with the parametric. It's not hard just to distinguish between them. Clear why we have a ft, gt, and ht? Clear? Good. Now you can see we have many things. We have many functions. This is also the value vector valued vector value. Why vector? Because I have an ijk component, right? Why function? Because coefficients are function. You can see from here and there and there. Okay. You see what? He said graph the vector function. So generally, graphing here is not easy, even for me, because the parameter t will change. Depends on the change, the graph will change. You cannot imagine 3 dimensions. For example, I say sine t cosine t is easy for me. But if I change the third one to another things, not t, actually it will be hard as well for me, because I'm not a, I'm not a machine. I need to think about it. So, sine cosine together will give you the circle. Sine square, cosine square will give you the circle, right? But when we change it to the circle, give you the circle. But when we have t with it, this is x, this is y, this is z. You know why? Because we have a I, J, K. Clear? Now, if I want to understand what's going on, we have a time helix. It's called helix, I think. Let me find the helix name. Helix. We have a helix motion or movement like that. It's going to up, like a spiral to up. Then I can imagine if I make x squared plus y squared or cosine squared, I'll get a circle. I am sure about that one, right? How about if I make t like that? For example, we say cosine squared t sine square t is equal to, for example, 5. I know this is the, or 25. This is the equation of x squared. Y squared is equal to 25. You know why? Because x is equal to r cosine squared. Do you remember that? In calculus 2, hello? X is equal to r cosine of t or theta. Y equal to r sine of t or theta. You remember. So when I say x squared, y squared, means that I have v squared. طبعا when r is 1, it will be what? It will be more clear. Good. Now I have a unit vector, a unit circle. I know it's like that. Let me change that one to here and t be 0. So I will get what? This is the whole picture in the 2 dimensions. But now I'm going to erase that one. I'm going to use my equation. T be to 0 to 2 pi. I know if it's t to 0 to pi, it will be like that. Or theta, you can call theta. Like point till I'll get that one, right? Good. Now, if I say, let t be from 0 to pi, I'll get what? Like a machine. If I'm working like a machine, I say, here's the first point, second point, third point, go. Final point. Am I right? Till pi. Am I right or not? Hello? So if I say 0 to not equal, just 0 to pi. What's going on? The circle, but there's a gap. Am I right? The circle with a gap. It's like a ring, but there's something missed. Why? Because t not 0, t is not 2 pi. So I start from other side till I get here and I stopped. This is where when z equal to 0. Am I right? We say that. If I say the equation x squared in 12.1, we mentioned that, and I remember. And z equal to 0 means that we are in the 2 dimensions. But when I say z equal to 5, I will get what? 2 dimensions, but just up. We bring the, if you remember, the garbage, right? The bin. And I told you the ring is what? Z is 0, 3, here's the circle. You agree with me? The 12.1. Good. Now, how about if I change this circle to be 5? 5.1 z at the same time. 5.2. What's going on? I'll get a circle, right? Clear. How about if I make t, z to be t, and t start from 0 to, for example, infinity numbers, and increase. So the circle will be like that, right? Because z will be what? Z increase from 0 z, and the first I'm in the ring on the table, then the z will be changed to what? The circle, try to construct, and it will become to up like a spring. Understood? So, or like a spiral. So that's why this equation, this graph, when I say cosine squared, it's in x squared in my mind. When I say sine squared, is y in my mind. When I say plus, for example, I'm a j. When I say k, tk, I know z is t. So z is increased, like a 0 to infinite. So that's why we will get such graph like that. It's going to up. So it's called helix. Understood? Clear, dears? Why like that? Because z is what is t. T may be 0, 1, 2, 3, 4. Maybe you say minus 1, -2, -3, -4. I think now it's clear. So maybe such example like that is easy for me, but the others don't. So careful and think about things. Because I got a function, so function has got a limit, has got derivative, has got integral. Am I right? We can say x squared has got limit of x squared. We can talk about derivative of x squared. We can talk about integral of x squared. Am I right? So now we are going to talk about, in these three chapters, the three sections, sorry, we are talking to easily, not deeply, just going to talk about limit and derivative and integral one by one. For example, if you have, this example as well is important. If you have function RT, it's a vector valued function, is equal to cosine t, sine t, tk. If I say find the limit t approach to 0, how to find them? So the answer is very easy. We are going to deal with them one by one. I separately, j separately, k separately. How? I have pi over 4. Okay, let be 0. So you know, cosine of 0 is what? 1. So I will write I say limit of RT when t approaches to 0, I, plus sine of 0, 0. So 0j. TB0, clear, 0. So I got what? Only I. Clear, dears? Can you do like that? I'm not going to bring the difficult limit, but you know how to deal with it. How about pi over 4? 45. So if you remember, we make a table. You remember? So sine of pi over 4 is equal to cosine pi over 4, fortunately, and it's square root of 2 over 2. Do you remember? We make a table in calculus too. So pi over 4, sorry, we will get I, j, and t is what? Pi over 4, directly. It's polynomial, simple. Do you have any question about the limit? Okay. So how about continuity of, one by one. Continuity of vector value function. It's okay. If it's a continuous in I and j and k, I say generally is continuous. If there's a discontinuity in one of them, it is discontinuous. And like a calculus one, but 3 functions. Now, look at the example. If I have this example, the previous one, sine, cosine, yalla, tell me this function is continuous or not? Cosine function is continuous or not, dears? Huh? It's continuous? Yes, thank you. Generally, right? It's like a wave, wave, oscillating. Okay, plus sine tj is continuous. Okay, plus tk. T is continuous or not? No?
Yes.
Yes? Now it's yes or no? Why? It's a polynomial. Polynomial is continuous everywhere. You know it's a polynomial, Kaka? Let me give you the polynomial. For example, if I say p of x equal to x squared or cube plus 2x squared plus 5x minus 2 is called polynomial. So maybe polynomial is monomial. وهذا يقدانا. Maybe polynomial is binomial. Maybe polynomial is trinomial. Maybe polynomial is a lot. So if one 2, 3 does not make a change. Is everywhere continuous. So, yes, 3 of them continuous. Do you think RT is continuous? Hello? Hello? Yes. Let me give you another example, simple example. RT equal to 1 over T I 5T squared J 2K. Is continuous or not? At 0 is not continuous. Just only the problem is where? That one, yes. That one is constant as well, yes. How about 1 over T? We have a problem at only 0. So I say it's not continuous at 0. Maybe my question is what? Is continuous at 5? Yes. Generally, yes. You got the idea how to deal? Good. Now, I'm going to next example. B. That one is continuous or not? And why? جماعتي discrete you know how to answer especially. And discrete يعني خلينا نبي. Computer science. Then computer engineer. يلا. Cosine continuous? يبقى نعلم yes. Okay. How about sine? How about this? What's your? No, keep it short. Okay, exactly. Yeah. Thank you. At least you remember. The function is called self function or floor function or the computer. But in the generally it's called greatest integer or lowest integer. Calculus 1, we have it. You can check your calculus 1 section 1. You will find the graph. I think I have here. Let me check calculus 1 for you. I have a proof. Let me see it's section 1 or not. If you saw Qadirma or stairs, please stop me. Here we are. Greatest integer or lowest integer? Here's the greatest one. Look at the shape, and here's the least integers. You got it? So you can see it's continuous or not, just by graph. Is it continuous? There's a gap, right? There's a gap here. So they are not continuous. But generally speaking, maybe you forget, it's okay. You can go to the graph. So that one is not continuous. So tell me, GT is continuous? Hello? No. You got it? So shall I repeat the Qadirma for you? The stairs? Now the stairs like that. Between 0 and 1 will be 0. Between 1 and 2, it will be 1. Between 3 is like that. Second. When we say, for example, 1.5, the result will be 1. I got 1.5 input input, I'll get what output? 1. So here is the gap. I'm a gap, all right? Continuous function should be like that. But now I have a gap here and gap here. Understood? Let's show a gap here. In each integers, the continuous, the 0 is not continuous, the 2 is not continuous, 3 is not continuous, minus 1 is not continuous because we have a gap. Gap here. Clear? Tamam. Forget it's okay, it's not a big deal, but you know how to find it. Every time you blame me that you say why mathematics does not have application. Now everywhere is application in calculus 3, right? For example, I'm talking about what? Velocity, speed, acceleration, unit vectors, motion. So all of them, especially in the field of vectors, in the field of valued function that we have in the chapter 13 in the calculus, Thomas calculus, totally all of them is application. For example, first derivative will give you velocity. Second derivative will give you acceleration. Value or magnitude of the v will give you speed. But in calculus 1, everything is beginning. Now, look at the example. Here's the vector. This is your car or your helicopter, whatever you say. Please find the velocity. So you know how to find it. You say velocity depends on the derivative. So how we find the derivative? That's a question. One by one. Like a limit. One by one. Derivative of cosine minus sine. Derivative of here equal to what? 2 cosine tj. That's what. Derivative of the third one. 5 yakım here. Kata chi aga 5 aga danemo. 2 cosine t multiply cosine is equal to what? Minus sine t. Kata yapacağım minus 10 sine t cosine t. Do you agree with me? Like a calculus one. It's easy. Shall I repeat it? No. So here's the velocity. Do you agree with me or not? Forget about that one. Do I need to perceive the chona I could as living? Clear? Hello? Okay. Find the second derivative. Here's the first derivative. Second derivative of here. Of here. And of course, many things here. Oh? Hello? Shall I do it? Derivative of sine, cosine, cosine, sine. T, 1. T squared, 2t. Kata, like this. Speed is equal to what? Magnitude of the first derivative. Okay? So, easy. Any question? Clear, Jamaat? Good. And with many things. Any question, any things? Awash, rule kana. Derivative of constant chanaga. Derivative of two functions, one by one. Derivative of multiplication, first derivative, multiply second plus. I'm not going to repeat it. Calculus, not calculus, at high school. The same thing. But now we have a problem here. We have a dot product, cross product. Careful from the cross. Even for the cross, the same. First, derivative of first, cross second, plus second, derivative of the first, like that. And of course, everything's clear here. Any question about 13.1?